Hello and welcome to the second video on ionisation energies. If you haven't watched the first one, just go back and watch it, and then this one will make a lot more sense. So let's get cracking. The first ionisation energies of group 2 decrease down the group. So here we have a graph here, and it's from BE to BA, and this is the increasing ionisation energy. So as we can see, it is going down, and this is the reason why, or the reasons. So number one, as you go down the group, the outer electrons are in shells further from the nucleus, so they're attracted to the nucleus less. This we did in our last video about ionisation energies, and this was atomic radius. So the atomic radius is getting bigger, and thus the outer electrons are less attracted when it gets to here, because the atomic radius is quite large compared to BE over here, and thus you can pull them off quite easily, and that means a low ionisation energy. The second concept that we have to learn here is that the amount of shielding increases because there's more filled inner shells. This means less nuclear attraction from the outer shells. So basically there's a greater shielding effect, like we did in the last video, meaning that the electron on the outer shell is the positive protons are shielded from it, so it's easier to just grab off, so the ionisation energy is lower, and that's all you really need to know about that for now. And then we're going to move on to this little fact here. So the first ionisation energies of period 3 generally increase across the period. So this is the reason why nuclear charge increases. So we did this in the last video about ionisation energies again, and we just said that if there was more positive protons in the nucleus, there would be more of an attraction between the negative electron on the outer shell, because they want to be together because they're attracted to one another. So that means that the ionisation energy will get larger if there is an increase in nuclear charge. And the second fact to note is that shielding stays the same, or you can say shielding is similar, and that basically means that there is not really a shielding effect that is affecting the ionisation energies. It pretty much stays quite similar across the period, and so it doesn't really have that much of an effect on the ionisation energies. Okay, so the next thing to point out is the subshell structure. We did subshells in the electronic structure videos, so if you haven't watched those, just go back and watch those if you don't understand what I'm talking about when I say subshells. And I'm going to try and explain this. So examiners absolutely love to put little questions on these little things here. Why does it dip down? I'm going to try and explain it as much as I can. So from Na to Mg, the 3s subshell is filling, and then we have this one here, Al, and the 3p orbitals are further out, so the outer electrons are easier to remove. That's why it dips down here, and then it just goes up because it's filling again, and then it goes down here again because the 2 electrons in the same orbitals means there is extra repulsion between the electrons, so it means it's easier to remove. So what I'm talking about is, so you have 2 negative electrons, yep, and because they're both negative, that means they repel one another, and if you repel something, then it's going to be easier to remove that electron, isn't it? So basically that's the reason why there, and you can see from up here the 3p subshells fill and they are spin pairing. So that is all I've got to say on ionisation energies. Thank you for watching, and I'll see you again soon.